Okay, so to start off with today, we're going to do some warm-up questions. Have a go at these questions to get started. I'm going to pause the video for a minute. All right, so our solutions here, we need to use Pythagoras' theorem in this first one, and that in order to find the side here, this is a right angled triangle, so we can call this one h, and h is equal to 17 squared minus 15 squared, which gives us 8. The area is half base times height, which gives us half times 15 times 8, which gives 60 centimeters squared. This triangle here is isosceles. Now, one of the properties of an isosceles triangle is if we bisect the angle at the top, we'll create a perpendicular bisector, making a right angle here, and this length here becomes this length. This is only true of isosceles triangles. You can't use that technique in this last one on the right there, because that one is not an isosceles triangle. So that means that this length here is 6. If we use Pythagoras' theorem again, we can find that the height here is going to equal 64 minus 36, which gives us, root 28, which is 2 root 7. So our area is then, on this point, make sure you're using a half times the base, which is 12, not 6, times 2 root 7. And that's going to give you, those 2's will cancel, and we get 12 root 7 centimeters squared. For this one, if you draw this line here that I'm drawing in both of them, it's called the altitude. So just add this piece of vocabulary. It's used quite commonly in American testing. So for instance, when you're doing map testing and SAT testing, they'll refer to this as being the altitude of the triangle. Now, we can't use Pythagoras' theorem here because we can't find the length of this line there. But we can use trigonometry. We're given an angle, so we can label this up. This makes this one the opposite, this one the hypotenuse, and we can say that the sine of 30 degrees is equal to the opposite, which is what we're after, over the hypotenuse, which is 3. What is the...
Because the figure of negative 90 degree, can't we use that to find the angle of 60 degrees? Because
we would use that for what?
for the base.
If we found that this was 60 degrees, we still couldn't find, you mean that the green base there?
Yeah.
Yeah, but that's not really going to lead us too far anyway. We could get through the problem that way. So you could find that one's 60, you could find that green line, you could use that green line to find the altitude, but that's two major steps. This is one. You're still going to have to use trigonometry to find that side. So why not go straight to the one that you want? What is the sine of
1 over 2?
1 over 2? So this gives us our opposite is going to be 3 over 2. So then we need half base times height again. So we've got the area is equal to a half times the base, which is 6, times the height, which is 3 over 2. So multiplying in fractions is easy. So we multiply the denominators together, we're going to get a 4. We multiply all 3 of the numerators together, 1 times 6 times 3. 3 6s are 18. 18 over 4. We can simplify that to 9 over 2. And that would be centimeters squared again.
Just a quick question. How did you get 3 over 2 when you went from sine 30 equals
Because sine 30 is a half. So this implies that, can I just change that from an O to an H? Because it looks like a 0, doesn't it? We change that to an H, that to an H, that to an H. And that gives us a half is equal to h over 3, and then we move the 3 up. Okay. We're going to use the area formula today. So we have the area formula is a half AB sine theta. We can practice some of our proof here. So we're going to create a proof for this. So I'm basically going to do that last question we just did, but in generalized form. So a proof, one technique into a proof is to take the exact problem with some numbers in it and do the problem with the numbers in it. And then you get the method of solution. We're going to repeat that exact same method of solution now, but using letters only. So what was the first thing we found? What was the first thing we found? The altitude. Nice use of vocabulary. So we want to go for the altitude here, which is the height. Let's make this right angle. So this height is equal to, what did we did this using the sine law. So let's say the trig definition of sine gives us the formula sine theta is equal to h over a, which implies that h is equal to what? Say
A sine theta.
a sine theta. When we're doing a proof, it's important, really, I always say it's important to reference the formulas that you're using when you create an equation. On proof, it's essential. So in order to create a proof like this, I have to reference the formulas I'm using. So the trig definitions are the ones that we're using here. So it's the trig definition of sine is sine theta equals opposite over hypotenuse. So the trig definition gives us this equation.
Do I have to write trig definition word for word?
Yeah. You have to reference. So in the same way when you write an essay in English or in history, you have to reference your sources. So in math, we reference our sources. And in this case, it's what formula is it we're using? Pythagoras theorem gives. A trig definition gives. So there isn't a correct name for any of these. The reader just has to know what you're talking about. So I call these the trig definitions because that's how these functions are defined. So that gives us this. And then the area formula gives area is equal to a half base times height. I'll quote the formula so you see which one I'm talking about. I'm doing this specifically because we've got two area formulas on the page, and that's the one we're trying to prove. So this is the one we have to use. Just be very clear. So that is going to give us a half times b times h, which is a half times b times, well, h we just calculate to a sine theta. So this implies area is equal to a half ab sine theta. When we finish our proof, we end with a QED. Quod erat demonstrandum. That which was to be shown has been shown. Yeah.
So area equals half times AB sine theta. That's just like the normal area formula we were using.
It's not quite the normal area really, because the normal one is half base times height. Whereas this one is a half times two sides and the sine of the included angle. So the way this formula works is you need two sides, A and B, any two sides. You have to have the included angle. That's the angle between them. So in a triangle, any two sides always touch. In a triangle, any two sides always touch. The point at which they touch, that's the angle you have to have. As long as you get that information, you can find your area. Quod erat demonstrandum is Latin. If you speak Spanish or Romance languages like que era demonstrado, that which was to be shown. It means I've done it.
We don't really need to know what it means, but every time we finish our piece, we write that.
You don't have to know what it means, but you don't have to have a good education.
So
You
what
can
I
have an
mean is,
average one if you want.
what I mean is we don't need to know what it means, but we have to write it at the end of each proof.
I mean what I said. You should write it at the end of each proof. You don't have to know what it means, but you can have a good education over an average one if you wish. Okay.
Can I take a photo?
Yep, I'll upload at the end, and then I'm videoing the class too. Okay, let's have a go at proving it that it's also true for an obtuse triangle. Have a go to this for yourself now. Let me give you a guide. The first part of this problem is to sketch the problem. You need to make an obtuse triangle, and then you need to find the right angle triangle that it's making. So draw an obtuse triangle, find the right angle, labeling sides and things that you're going to do to show your proof. This proof is the same as that one. So I'll leave this one on the board for now. I'll leave this one on the board, but you're going to make your own diagram. And this is the hardest part, making the correct looking diagram. So just draw an obtuse angle, scaling triangle. Label some sides, label an angle. Look how I've drawn it here. The proof is the same, almost. There's one extra step. There's one extra step. Have a go. I'll pause the video. Do about 5 minutes on this one.
We switch into back really good to the last time.
Okay, so have a go at your obtuse angle proof. I'll pause the video for 5 minutes. Okay, if you're stuck at this point, what we need to do is we need to draw B as the base, horizontally flat. Put your theta next to the base, over here on the right-hand side. So that means we are going to get our base like this, and then we need an obtuse angle like that. We would need to make a triangle with a third side, and this is an obtuse angle triangle. And you want to label it up so that here is B, here is theta, and here is A. So that theta is the included angle of A and B. This is the starting point. Now, ask yourself, where is the height in this triangle? Where is the right angle triangle that has the height in it? And what is the angle at the opposite side of the height? Yes. So we've got the diagram now. Oh, it's a sine.
Yeah, you go from it, yeah, the altitude here.
Why can't we do that?
Yes. Let's have a look at our proof. So we've got our triangle drawn. We need to have the height of this triangle. So the height of this triangle is there. That's the height of the triangle. So we can extend B to meet that, and we can create a right angle triangle like this. So we now have a right angle here. So we only know one of the angles at the moment in that triangle. We know the 90. But we can find one of the other triangles. We can find this one in the bottom left corner. What's it going to be? So this angle here is 180 minus theta. Brilliant. We're after the height, and we know the hypotenuse. It's A. So let's do the proof. Trig definition is sine of 180 minus theta is equal to the opposite h over a. Okay, can we simplify sine of 180 minus theta? Can we simplify that? So if we take the unit circle, like this one, and we have an obtuse angle over here, such as 180 minus theta, we can draw a straight line across here, because this is the sine of 180
So then
minus theta,
it's
y equals.
it's 0 minus theta, right?
So
Just theta.
this angle here is going to be theta.
It should
So
be
this is also the line y is equal to sine theta. And one of the formulas you're starting to see, and you will see it regularly, is this relationship with sides. This is a crucial formula. Sine theta equals sine 180 minus theta for all angles.
So is that using like isn't that like
Using
double
unit
alpha
circle. Using,
double alpha formula?
no, it's using the unit circle. So this diagram proves it. The unit circle proof. So if we have an angle here, which is 180 minus theta, it means that this angle is minus theta. So this triangle has to be congruent with that triangle there, which means their heights in this direction, their y values have to be the same. So this horizontal line is the line y equals sine theta. It's also the line equals y equals 180 minus sine theta, because they have the same y value at these points. And this diagram leads us into this relationship that we saw a couple of weeks last week or so. Sine theta is equal to sine 180 minus theta. So we can use that. So this implies then that sine theta equals h over a, which gives us h is equal to a sine theta. And then the area formula gives area is equal to a half base times height, which is equal to a half b times a sine theta, which is a half a b sine theta QED. So the only difference between this proof and the last proof is you have to draw a new diagram. And you've got this one simplification extra. Otherwise, it's identical to the previous one. We're going to move on from that. You need to take notes, take them later, because we do need to move on from this one. So, have a go at using the formula now to calculate the area of this triangle. I'll write the formula up. Half a b sine theta. Use your calculator.
I was asking, like, for example, like what is
We're not doing the compound angle identities. This would.
that work?
Yeah. You can prove that formula using the compound angle identity. Because the sine of
Like
180
sine
is,
180 cos b1 minus cos 180.
but this cancels the sine 180
Yeah.
is 0, and this one gets rid of the minus sign.
Okay, so
Okay. It would, the cosine of 180 is minus 1. So next you need to put in your tree values for these.
okay, so minus 1 is 0, so 0.
Cancel that and simplify that.
Oh, okay. And then minus 1. Okay.
Those are not the double angles, they're called the common angle.
Common.
The
Yeah.
double ones are different.
Compound angle, I think this is the rest of the facilities of the words in the beginning we used that one was in the beginning because
I said,
this is so hard.
this is easy. Just new.
So what's the hardest unit?
Okay, so let's have a look at how we solve this one. This one is super easy. So the area is going to be a half times 16 times 9 times the sine of 25 degrees. So over to our calculator. I don't tend to put in the half times 16. If one of these two numbers is even, look, 16 is even. So that's 8 times 9 times sine 25. So in your next step, as you move on to your calculator, sometimes you can instantly just cancel that half and halve one of the numbers. So I'm just going to type this in as 8 times 9 times sine of 25. Check that your calculator is in degrees on the top left corner here of the on the top left corner, but it's in degrees and not in radians. You get your answer. If you get one of these answers, press Control Enter for a decimal. And we have that the area is equal to 30.4. This is to the nearest tenth it's asking there. So this is just a formula, just plug numbers in. Super easy.
Is this from like, is this opinion Excel? Or
Yeah.
This?
It's just 2 IXLs or 3 IXLs for homework.
Would the answer be different just with after 16 and the 9 more?
No.
It would be the same.
16 times 9 and 9 times 16
No,
is the
I
same.
mean, like, would the answer, would it like impact if we did half times 9 times 16?
No.
So it's fine.
2 times 5 is 10. 5 times 2 is 10.
I need to like in the calculator 8 instead of 16 times 8 is 5. So we did that in areas
Yeah, but this is easier.
Oh, I don't see that. Yeah, oh yeah. But it's because you were in.
Because I'm assuming like where I don't know.
Doesn't give you those numbers.
Is it always that like the see that?
It's always half times AB
But that's what we said at the
sine of the
beginning.
included angle. This word included angle means that theta is between the two, no base, rather than indirect. By 2 sides, that means the included angle. Okay,
Either way, you flip the.
we need to prove the sine rule. We need to prove the sine rule. So proof of the sine rule is quite easy. What we're looking for the sine rule is, we've got that the area is equal to a half times A times B times sine. So if I draw a more generalized triangle, I won't use theta this time. I'm going to call this A, B, C. So when you're labeling a triangle, when you're labeling geometrical diagrams, sides are lowercase because the vertices opposite are capitalized. So if we want, this one is A, this vertex here is B, this vertex here is C. So generalizing it here, we get the vertices. It's not very handy with C and capital C when drawing by hand, but try and make them look different. So we can say that this is a half AB sine which angle? We don't have a theta in the diagram. Which is the included angle of A and B? C. The area is equal to BC sine, which is the included angle of B and C? A. So I'll call this area. Half, which ones haven't we used? AC, sine. What is the included angle for sides A and C? B. So these are all equal. So if I take 2 of them, like these 2, that implies that a half AB sine C is equal to a half BC sine A. What can we simplify from this? We can simplify the halves. We throw the halves away.
And these.
And the b's. So if I simplify that, I get A sine C is equal to B sine A. No, sorry, C sine A. Let's rearrange it a little bit. A over sine A is equal to C over sine C. And this is a part of the sine rule. This is a part of the sine rule. I could repeat that calculation for each of the three pairings and come up with an equivalent one. So I'll just say repeat for each pairing. And it gives us the formula A over sine A over sine A equals B over sine B equals C over sine C. And that's the sine rule. We could take the reciprocal of that, and it would give us sine A over A equals sine B over B equals sine C over C.
So, you said about the right side, this side, do the absolute is cancel out.
Yeah. I'll put a red line. So that cancels that and we get this. That's an easy proof. The thing with proof is so if I was asked to prove the sine rule, I would start by proving the area formula. So the thing with proof, you can use anything you've previously proven. So I start with the area formula and then use that to prove the sine rule. It's very easy. Easy. Okay. If you want to go, I'll go through the questions that are going to be on the next test and watch them later. All right, so have a go at using that formula now to find the length of E.
So
You need to write it down and use your calculator.
is it E over 4 equals
No,
E over 11?
no, no.
E over
What's the rule called? And after you use that, E over sine 111 is equal to
14 over 14 sine 45.
yes.
Oh, but it's just cross multiplication.
And what's our angle? Maybe not just first time. I'm going to add, find out what.
Do I need to bring my red pen and success? Two ratios.
Yeah.
Use the 45.
How does that help?
Okay, let's have a look at a solution here. So there's two forms of the sine rule. If you're trying to find a side, start with one of these. So start with two of these. If you're trying to find a side, start with two of these. If you're trying to find an angle, start with two of these. This one's easier to simplify for angles. This one's easier to simplify for sides. We're after a side. So we say that E, let me do it. E, so E is here. What's the side of the angle opposite? 111. So E over sine 111 degrees is equal to, we need another number, we've got 14. And what's the angle opposite? Sine 45 degrees. That implies that E is equal to, we just move this number up. 14 sine 111 over sine 45 degrees. On a non-calculator exam, that's the answer. That's the exact answer. It's the only way of expressing the exact answer. But on a calculator paper, you'll be asked to round. We need to round to the nearest tenth. Let me do it for the sake of the video on the calculator here. So we need control divide, quotient, 14 times sine of 111 divided by the sine of 45, control, enter. 18.5. If you notice, I've set my calculator up to give me to the nearest tenth for this exercise, reminding you how to do that. Document 7.2, and then change this into fix 1. It's asking for to the nearest tenth. Fix 1 is the nearest tenth. And then we get our answers. If you don't want to do the control enter, on that screen is where you sort of move between the different formats of the calculation mode. It will vary how it works on this one in your calculation mode. Some of them have it all under calculation mode. Other ones said whether you turn exact arithmetic on and off. This one, some of them have 3 choices here. Depends which version of the operating system you're running. So that saves you having to press Control Enter. You just press Enter. But it's annoying if you forget to switch it back on because exact arithmetic is good. Let's move on. Have a go at this one. I think it says find the side V. Have a go at this question. Going for time?
Maybe I'm not sure.
Can I have my table back now?
I don't have any book.
You don't have to go to the top on your computer? What kind of a computer do you have?
This is 15, 23, 13.
It's super. This question.
It's complicated, but because it's new, on both sides of the equation, there's one variable that's missing.
No. You can't have 3. You can't have 3. So it doesn't work. Okay, let's have a look at a solution to this one. Let's have a look at the solution. So start off, we are after V. We are after V. That's this one. So we need to use that angle. So we start off with V over sine 13. Now we need a ratio. If you notice, we don't have T. We have this one. So we need that angle. So we've got 15 over the sine of that angle. Well, how big is angle U? 144. So 144. Angle sum in a triangle will get you that. 180 minus 23 minus 13. 144. Pop this into our calculator, and we have V is equal to 15 sine 13 over sine 144. Fifteen times the sine of 13 over the sine of 144. And 5.7. Check that your number seems right as well. If this comes out as 0.32, you're in radians or something like that. If this is 15, then these two have to be less than 15. But they can't be, they have to add up to be 15. So the way that triangles work, that's the obtuse side, the longest side. So these two have to be less than 15, but the sum has to add up to 15. If this is about 6, will these add up to that? Yeah, it looks about right.
How did you get to sine 24?
Angle sum in a triangle. We didn't have angle u. We wanted angle u because we had side u, the 15. So we use the angles 180 minus 13 minus 23.
So we could have done the opposite. If we had all this.
Yes, we can.
So always take the opposite angle, right?
Always, 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 always.
So it would have been the opposite where we had like we had an angle on this side, we had other two sides.
We haven't got there yet. We'll get there. Okay. Only 3 IXLs today. Have a go at one of these. Make sure you finish one of these during class time, and that you have 2 left for homework. Start these now. Yep. Now is the time to go to the bathroom. This is tomorrow.
So is there a cost? So we're gonna set them in So is there a cost?
Does that match? This time day free trial. Make sure you use your calculator for these questions. And that's it for today.
We're gonna upload this part when